Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your module, that is the procedural programming module. In the last class we have started with chapter number 15, that is a miscellaneous feature. I'm going to continue with the same chapter, that is chapter number 15, miscellaneous features. I have started with the chapter, that is the basics of the chapter, what are the miscellaneous features that is available in the C language. So let's take a quick review what we have covered in the last class and then move to the next part, that is the continuation of this chapter, that is topic of the today's class is Typedef. That is, I'm continuing this chapter with the Typedef. So in the last class we have started with chapter number 15, that is miscellaneous features. These are the various topics that is available in chapter number 15. In the last class we have discussed the enumerated data type. Then in the today's topic I will be discussing the typedef, typecasting, bit field. So these are the various topics that is available in this chapter number 15. Then we have discussed what is the enumerated data type. So till now we have covered the various data types like int, char, float. Now the another data type that is available is enumerated data type. We have also covered the user defined data types like structure, union, but this is a enumerated data type. So this is a different data type. We have covered the predefined, that is integer, float, char, as well as the user defined like structure, union, arrays. But this is the enumerated data type that takes the value of the variable by starting with the 0. That is the first enumerator that is given is stored or is given a value as a 0. Then second enumerator is given a value 1, third is given a value 2, and so on till n number of enumerator we are using. So that is the enumerated data type. So this says enumerated data types gives you an opportunity to invent your own data type and define what value the variable of this data type can take. This can help in making the program listing more readable, which can be an advantage when a program gets complicated. This means whenever we are whenever we get the input and whenever we take the input as a source, so we get the input and make the efforts for making these programs valuable. So enumerated data types is used for defining the values that is available in the C programming language. As an example, one could invent a data type known as the marital status, which have four possible values, that is single, married, divorced, widow. So this is the example of the enumerated data type. How we can define? This is the structure. This is like a structure variable or structure data type. The keyword that is used is enum. So this is the keyword that is used, that is the enum, and the name of the enumerator is mar status. There are four types of operators, or there are four types of enumerator that is used. One is single, one is married, one is divorced, one is widowed. And then declare the values or declare the variables of the enum marital status, that is person 1 and person 2. So these are the two variables of the type or marital status that is of enumerated data type. Then we have discussed how to give the values or how to allot the values. This is the way how we can give the values. Like person 1 is allotted the value as a married, person 2 is divorced. This is generally same as the structure, but the main difference is that it takes the value as a 0, 1, 2, and so on till n number of enumerators. Like in this example, single is assigned a value 0, married is assigned a value 1, divorced is assigned a value 2, and widowed is assigned a value 3. Now, then we have discussed how to give the values of the enumerators. That is, there is also a provision we can also give the values of the enumerators by defining like this one. Like single equals to 100, married equals to 200, divorced equals to 300, widowed equals to 400. So these are the various values that is given into the marital status, mass status, that is of enumerator type. Now main thing is that this is always terminated by the semicolon. Then next is enum mar status person1 person2. So these are the two variables of the enum mar status. Then what is the use of or uses of enumerated data type? That is why we are using or what are the uses of enumerated data type? This says enumerated variables are usually used to clarify the operation of a program. For example, if we need to use employee department in a payroll, we can define or we can list it by using the values like assembly, manufacturing, accounts rather than the value 0, 1, 2. This is the example that defines if I want to give the name of the department of the employees. Then we have to use the enum that is of employee department that has a different values like assembly, manufacturing, accounts, stores. This is the example that we have discussed with the practical approach also, with the theoretical approach also. Then we have discussed about the explanation of this example. What is the meaning of enum? What is the meaning of variables? Why we are using the structure variable? That is what we have discussed in the last class with the theoretical part as well as the practical part. Then we have discussed why we are using the printf and the scanf values. This says the printf is not smart enough to perform the translation. The department is printed out as a 1 and not the manufacturing. Now, then we have discussed why or what is the advantage or why are enum necessary? This is the question. That is, if I don't want to use the enum in my C program, it is possible to execute the program? The answer is yes, it is possible to execute the program. How it can execute the program? By using the macros. So there is an alternative to the enum that defines the value by default as a 0, 1, 2. So in the same way we can define the value by using the macros. So the macros is used by using the hash define. That means defining the value of assembly to the 0. So macro is always used with the hash define, that is hash define assembly 0. Then hash define manufacturing 1. Then hash define manufacturing 1. Then we have discussed about these things, that how we can define these variables, how we can use the macros in place of the enums. So how it will be used? By using the hash define. Then there is a keyword that is, for example, assembly, that is given a value 0, manufacturing 1, accounts 2, stores 3. So these are the values that is given by the macro. Instead of using the enum, we are using the macros for defining the value in a global state. Then we have discussed about this definition or this paragraph about this, why we are using the enums, or what is the advantage of enums, or what is the comparison between enum and the macros. So this is what we have studied in the last class. In the last class we generally focus on the practical approach so that your concepts are clear. Today also I am going to cover the various practical approaches so that your concepts are clear. Then next forward to the next part, that is I am going to start with the today's topic, that is the renaming data types with the Typedef. So enum is over. Now the next part is how to rename the data type. That is, suppose my requirement is that my target is that to rename the data type with the Typedef. How is that possible? This is also possible. That is, there is one more technique which in some situations can help to clarify the source code of a C program. That is, this is a technique that is available to clarify to change or to use the source code of a C program. This technique is to make use of the Typedef declaration. That is, this is used to make the declare, or this is used to change the uh, type of the data type that is done by the typedef declaration. Its purpose is to redefine the name of the existing variable type. That is, we can change the data type, we can define the, or the main purpose of using the typedef is to redefine. Redefine means again defining the name of an existing variable type. For example, consider the following statement in which the type unsigned long int is redefined to be of type 2 words. That is, my target is to uh, use, that is, change the name of the unsigned long int to be defined as of those of the 2 words. That is, changing the name of unsigned to the 2 words. How is that possible? Simply use the typedef keyword. This is the keyword that is used exactly, that is a typedef, then uses the old name that should be replaced with the new name. That is unsigned long int, this is the old name, the new word is 2 words. So 2 words is the new name, unsigned long int is the old name, and typedef is used to declare or to define the new name instead of the old name. That is how the name of the data type is changed by using the typedef operator, by using the typedef keyword. Now we can declare variables of the type unsigned long int by writing this one, 2 words. Why? Now this unsigned long int name has been changed, but the motto is same, or the responsibilities, or the execution part, or the everything is same, but only the name is changed. So if I want to use the unsigned long int, then I have to use the 2 words. Why? Because the name has been changed, but the rules, regulation, everything is same. That is, the name has been changed as a 2 words, right? So this is 2 words, var1, var2. That is variable 1, variable 2, and 2 words is the keyword that is used to define the typedef unsigned long int. So this is how the we can change the name of the data type. That is, this is the provision that is used to change the name of the data type. Then next point, instead of writing this one, we can also write unsigned long int var1, var2. So this is also a provision. We can write this one for defining the value. Next point says, therefore, typedef provides a short and meaningful way to call a data type. That is, this provides a meaningful way. Suppose I don't know what is the unsigned int, but I know what is the meaning of 2 words. So this provides a provision that how we are using this one, or how we are using the, or how we can change the data type, or we can change the name of the data type, and it is used by every operator, every provision that is understood by this one. Now this provides a short and meaningful way to clarify or to call a data type. Usually uppercase letters are used to make it clear that we are dealing with, or we are dealing with the renamed data type. With the increase in readability is probably not great in this example. It can be significant when the name of a particular data type is long and unwieldy. So this says the main advantage of using the typedef is that whenever there is a long name for the data type, so this is more beneficial in those scenarios, as is often with the structured declaration. For example, this is the example. We have declared the structure, that is the employee, that contains 3 parts. One is the employee name, one is the age of the employee, one is the basic salary of the employee. Then defining the variable of the structure type, that is employee, that is the variable name is E. This structure declaration can be made more handy to use when renamed using typedef as shown below. That is, this structure declaration can be made or can be useful whenever we define the or whenever we change the structure name, that is employee, with the another name. So how this can possible? First of all, the same, defining the structure that is done by the struct keyword, then employee, then name, age, basic salary, right? Then uses the typedef, that is typedef struct employee, that is Meaning of this line is that the employee structure is converted or is given a new name. What is the new name? That is the EMP. Now, declaring the variables of the structure by using the EMP, not the struct employee. That is, typedef is used to change the name. Now, take the name or took the name of the new word. For example, EMP. For example, DMP. So now declare the variables like E1, E2 by using the EMP, not the employee structure. Therefore, by reducing the apparent complexity or length, Typedef can also or can help to clarify source listing and saves the time and energy spent in understanding a program. This says whenever we use the Typedef, it first of all saves the time because we do not have to write long name again and again like struct employee. Instead we can use EMP. This is a short name. The above Typedef can also be written as this one. This is also written as this one. Instead of using Typedef over here in this line, we are simply rotating or we are simply use the Typedef over or in against of or in before of the struct employee. This is Typedef struct employee. There is a curly braces char name 30, that is name of the employee, that takes 30 variables or 30 characters. Then int age, then float bs. So int age means that is the age of the employee, then float bs, then defining the variable of this one like this one. The same example as we discussed in the structure. Now the structure name has been changed to the EMP in the first instance only. That is in this line, the first line, the struct employee is changed to the EMP. Now declare the EMP variables, that is E1 and the E2. This is Typedef can also be used to rename pointer data types as shown below. That is, we can also change the name of the pointers or we can also rename the pointer data types as shown below. This is the struct employee, the same example. Now I have declared the struct employee pointer by using the Typedef struct employee PEMP. This means the struct employee instead of struct employee, now I am using the pointer, that is the pointer EMP, that is the PEMP. Now declaring the values of the PEMP, for example P, now uses the arrow operator for defining the values like P arrow age equals to 32. So this is how it can be done. So in simple terms, Typedef is used to change the name of the data type. Suppose I want to change the name of the data type, that is name is so lengthy or that name is not suitable. Then how I can change the data types? By using the Typedef PMP or by defining the pointers of the Typedef. Right. Now the next topic or this topic is finished as the Typedef. Now let's move to the next part, that is a just a minute. First of all, I have to do one practical example of this one so that your concepts are clear, right? So let's take a practical approach of the Typedef, then move to the next part, that is the typecasting, right? So I'm doing the practical approach for the Typedef. First of all, the header files are included. For example, I have included the same header file, that is hash include stdir.h, hash include conio.h, then uses with the void main, starting with the void main. Suppose I've declared one variable that is of int, so I use typedef. This is the keyword typedef int rs. That means in place of int now I will write rs. Why? Because this rs will replace the int keyword. Now I have to define the integer values, then I have to use rs. For example, I have declared one variable. For example, rs, and there is a variable that is hrs, for example, right? Then uses the clear screen. Then uses the printf. Now defines the enter the r's. Then uses the semicolon. Then uses the scanf. Now uses the or scan the memory, that is the r's, that is hrs. Now print the values of this one. Here I have not declared the values of the h, so simply print the values of the r's, that is r's equals to %d. Why %d? Because it is in integer. Then simply prints r's. Then uses the getch for output. Then closes this one. So this is the example of the typedef, how typedef is used. Now let's compile this one. There is zero error, there is a success. Now let's execute this one. Enter the r. Suppose I have entered the r as a 34. So the r displays it 34. The main concern of writing this program is to understand how typedef is used. So typedef is a keyword that replaces the int, float, any data type to the new name. Now instead of using the int over here, I am using the r's. Why? Because the new name of int is given as a r's. Suppose I have to use this one. For example, instead of using this one, I have to use float. The same concept, if I compile this code, enter the r, for example 23. So r's is 0. Why? R's is 0 because here this is %f, not the %d. Here it is also %f, not the %d. Now if I compile this code, enter the r's, that is 23.000. Why? Because it is in float right now. Clear everyone? So this is the example of the typedef. So I have saved this program with the typedef name. Now let's continue with the same topic, or let's do one more program for the typedef. In terms of the structure, for example, the same example that we have done. Suppose we have used the void main. This is the void main. The new concept, that is hash include lastdio.h. In the same way, hash include conio.h. The same concept. Then uses the void main. Then declare the structure as a typedef. For example, I have given the typedef, that is typedef is a keyword. For example, if I am using struct, right, then uses the curly braces. This is proper indentation. There is no indentation. Where is a void main curly brace? There is no void main curly brace. then uses the char name, that is 20, right? In the same way, I have declared, for example, char or int age, right? Int age, this is also in this one, because this is int is in, or int this is in float. For example, if I'm using one more variable, that is int account number, that is AC number. Now this part is finished. Now give the name of the structure as an info. So this is the info, for example. Now define the variables of the info as this one, info employee. So this is the variable of the employee or info employee. For example, this one. Now if I'm defining the values of the employee, how I can define it? By using the semicolon. For example, I've given the name Harry, then age is for example 23. Now the account number is for example 125. Then this will be closed. This is given a value. Simple uses the CLR SCR, right? Now print the name, print the age, print the salary, or print the account number. Now how I can print these values? Simply uses the printf statement. First of all, name is percentage %s. Why we are using percentage %s? Because this is percentage, or this is in string. suppose I've declared this one as a info, right? And I remove this one. Now what is the error? There is only one error, cannot convert int into the info. Info is only a structure name. This is 23. Let's see over here. This dot operator is used. Any student, anyone who can tell me what is the error over here? Hello? Yeah, anyone can tell me? Yeah, anyone can tell me what is the error over here? Yes? Yeah, Olesam, are you able to hear me? Yeah, can you tell? Yeah, this declaration is the same one. This declaration is same. Semicolon is same. The name is same. Age is same. This semicolon, this is mandatory. If I do not write this one, there is an error. Let's see. There is no semicolon after void main. Yeah, it's mandatory to give the semicolon at the end of this one, like this one. Okay. No, no, no. Yes, yes, I agree with you, but I'm just trying it. Okay. Here, uh, there is no semicolon in the structure only. There is no semicolon that we define in the structure. That is not. Yes, equals to sign. This one. There are two. Yeah, there are two errors right now. Yeah. I got the solution. This is not a bracket. This is the curly braces. This is the curly braces. Now, if I compile, there is a success. Oh, thanks a lot. This is not a equals to is okay, but this is not a bracket. This is a curly braces. That's the main error. Yeah, yeah. It's mandatory to write the curly braces over here. Now again, I'm doing the same task. Yeah, I'm doing the same task. Now, if I compile this code, there is a success. There is no error. If I execute this code, the name is Harry, the age is 23, and the account number is 125. This is not displayed in the next line because I'm not using the slash n over here. If I use this one, slash n, now it will be executed in a similar way. Name is Harry, age is 23, and account number is 125. So this is example that shows how typedef will be used. Simple use the typedef, give the structure name. What is the structure name? The structure name is info, then uses the employee, then Harry 23 125. So this is how we can give the structure name by using the typedef. That is, typedef is used to give the structure name or change the structure name to the info. So info is the new name for the structure, right? Now let's move to the next part, that is the typecasting. Now this is saved. I have to save this file, that is typedef1. Now typecasting, that is the next part. This says sometimes we are required to force the compiler to explicitly convert the value of an expression to a particular type. That means there are some situations or there are some conditions in which we are required to force the compiler. We are required to force the C compiler to explicitly convert the value of an expression to a particular data type. Hello? Yeah, is that visible? Is that visible? The screen is visible to you? Okay. So typecasting means whenever we force the compiler to explicitly convert the value of expression to a particular data type, that is done by the typecasting. Suppose I force the compiler to convert the value into the float. Suppose it is an integer value. Or next example is, suppose I tell the compiler to convert the values into the string, that is a character string. So we are also required, or we are required to force a compiler to explicitly convert the values of int or expression to a particular data type. This would be clear from the following example. This is the example. There is a void main, there is a stdi.h. Now declare the values or the variable as a float, that is a. Now using the int, that is x equals to 6, y equals to 4. Using the taking the value of a, or taking the value of x divided by 4 and store the value in the a. But a is in float value, so uses the percentage f for storing the float value. The answer turned out to be 1.000 and not 1.5. Why? Because 6 and 4 are both the integers, and hence 6, 4 is an integer 1 only. Why? Because this says that both the values are of integer type. This 1 when stored is converted into 1000. That is, whenever we have to convert this into the float, this becomes 1.00, not 1.5. But what if we don't want the question to be truncated? That is, if I don't want that the 1.5 becomes 1.000 automatic by the C, the solution is to make either x or y as a float. Let us see how this can be done, or how we can perform the typecasting by changing the value of, for example, integer to the float. This is the same example, the void main float. Now instead of using the a equals to xy, I am using this one, a equals to float xy, x divided by y. That means we have declared that the x and the y is of float type. That means converting the values of x divided by y into the float value, then and only then store the value in the a, that is the variable a. So this is the example that shows how to convert the integer value into the float by defining or by using the float keyword instead of, or in place of, or in before of the x divided by 5. Now the value of a is a, that will be printed by using the percentage f. This is the output. The value of a is 1.5. This program uses the typecasting. This consists of putting a pair of parentheses around the name of the data type. This is a parenthesis, that is available around the name of the data type, that is a float. In this program we said this one, the expression float causes the variable x to be converted from the type into the float before being used in the division operator. So this causes the x to be converted into the float, y to be converted into the float, and the output is so obvious automatically converts into the float. This is another example of typecasting. This is another example. This is hash include stdio.h. There is a void main. There is a float a equals to 6.35. That is, we have declared one variable as a for a as a float. That value is 6.35. Now printf the values of one of a typecast, that is int a. That means converting the a into the integer value. Then printf value of a is a, simple percentage f. This means in first printf statement we are forcefully tell the compiler to give the value of a as an integer, not a as an float, but give the value of a as an integer. Why? Because my requirement is that to get the values in the discrete value in the integer value, that is converting the a into the integer. In the next line, simple value of a will be printed, that is in float form. Now this is the output. The value of a on typecasting is 6. Why? Because now 6.35 is converted into the 6. Why? Because we are using the integer a. That is, we are supposed to, or we are forcefully tell the compiler to convert the a into the integer. Then the next expression or next printf statement gives the float value, because in this there is no typecasting, there is no conversion of int into the float. Now note that the value of a does not get permanently changed as a result of typecasting. Rather, it is the value of the expression that undergoes type conversion whenever the cast requires. So this says the value of a does not get permanently changed, but it is only changed in case of the typecasting operator. This is the most important line. Most of the people think that the value is automatically or permanently changed. No, that is not possible. But the value is changed only for the temporary basis. Whenever we execute this code, the value again retype or rechange into the float value, because the main or the original value is in float, but we have forcefully converted into the int. So whenever this code will execute, then automatically the value becomes float, because the original value is in float. So this is typecasting. In simple terms, whenever we have to convert the data type, that is from one data type into the another, for example int into the float, float into the int into the char into the int. So that can be done by using the typecasting. After a break, first of all let's take a break. After a break, I am continuing with the practical approach of the typecasting, then moves to the next part, that is the next topic, that is the bit field. So first of all let's take a break for 10 minutes and then come back, starting with the practical approach of typecasting. So let's take a break for 10 minutes. Let's continue with the session. So come back from the break. Let's continue. So we have discussed about the typecasting. Now let's take a practical approach on the typecasting. That is how typecasting is done. So let's take a practical approach of this same example. For example, this one. So let's take a practical approach of this example only. Suppose let's see. For example, we have included two header files. Now void main. Now suppose I am using int a, or that example is on float. I am taking the same example, float a. Right. Now you declare the values of x and the y. For example, x has a value 6 y has a value 4, right? Now uses the a equals to x divided by y. Then printf the value of y, value of a is percentage the f, this is in float. Now print the value of a, now get ch. Now if I compile this code, there is a success, there is an, what is the value? That is 1.000, that is converted into the float, right? Because the a is in float. Suppose my requirement is that I have to divide, when divide 6 divide by 4, the output is 1.5. Now I change by using the typecasting. I have to use the float over here, like this one in brackets. Now if I compile this code, there is no error. If I execute this code, there is no error, but the output is 1.5000. Let's see the output. The value of a is 1.5000. Suppose the same example I have converted into the int. Now what is the output? Value is 000. Why? We are using percentage f over here. Suppose I have changed percentage f into this one. The value is 1. Why 1? Because it is of integer type. Everything is integer. Integer, but it is converted into the float. Now if I change this one into the float, so this must be changed into the integer so that the output is in integer form. Now if I execute this code, the value is 1. Why? Because this time it is in integer. So when x divided by 4, that gives the float value, but my target is to convert into the integer. So this is known as the typecasting, right? So I have used this one, or used the name, that is typecasting, this one. I have to save this file, then uses the typecasting. This is the typecasting, right? So this is the example of the typecasting. Any doubt, anyone? Now move to the next part, that is the bit fields. That is how we are using the bit fields in this example. Any doubt? Any doubts? Anyone? No. It's okay. Now this says if in a program or a variable is to take only two values, that is ones and zeros, we really need a single bit to store it. That is, if it is a program, or if it is there is a one program in that variable is to take only two values, either zeros or ones, we really need a single bit to store it. That is, we need a single bit to store the zeros or ones. Similarly, if a variable is to take values from 0 to 3, then 2 bits are sufficient to store these values. And if a variable is to take values from 0 to 7, then 3 bits will be enough. How it can denote? Because 0 and 1, this is the 2 bits and single bit is required. If it is 4 bits, then only 2 bits is required. If it is 8 bits, then only 3 bits is required. Why? Because 2 power 3 is equals to 8, 2 power 2 equals to 4, 2 power 1 equals to 2. Means it takes the you are not able to see the screen. Everyone is not able to see the screen. Hello? Now it's okay? Yeah, now it's okay. Now it's okay. You are able to see the screen. Just a minute. Now it is visible. Now it is visible. Okay. So this says if a variable can take two values, that is either 1 and 0, we need a single bit to store it. Why? Because 2 power 1 is equals to 2. Similarly, if a variable is to store or take a value from 0 to 3, that means if a variable is to store 4 values, we need only 2 bits. Why? Because 2 power 2 is 4. Next, if we are able to, or a variable takes value from 0 to 7, that is the 8 bits, then the 3 bits are required or enough to store them, because 2 power 3 equals to 8. Why waste an entire integer when 2 or more 3 bits will do? Well, for one thing, they are not on a 1 bit, 2 bit or 3 bit data type available in C. However, when there are several variables whose maximum value are small enough to pack into a single memory location, we can use bit fields to store several value into a single integer. This says we are using, or we are denoting the bit fields, we are using the bit fields so that the output or the input will be stored in a bit level, that is in a smallest level. There is no wastage of the memory, there is no wastage of the resources of the compiler of the operating system. To demonstrate, to see how bit field works, let us consider an example. Now let's take example. Suppose we want to store the following data about an employee. Suppose my target is to, or my motto is to store the following data about an employee. Each employee can be a male or female, that is, the employee can be of either male or female, married, unmarried, divorced or widowed, having one of the 8 different hobbies, can choose any of the 15 different schemes that are proposed by the company to pursue his or her hobby. This means we need 1 bit to store gender, 2 to store marital status. Why? Because these are the 2 values, then we need only 1 bit. These are the 4 values, then we need the 2 bits. 3 for the hobbies, because it is the 8 values, and 4 for the schemes, because it is of 16 values. We need 10 bits together altogether, which means we can pack all this information into a single integer, since an integer is 16-bit long. To do this, we using the bit field, we declare the following structure. How it is declared? First of all, using the struct keyword, then what is the structure name? That is the employee. So employee is the name of the structure, then struct employee, then declaring the values of unsigned gender, that has a value 1, unsigned marriage status, that is a 2, unsigned hobby, that is a 3, unsigned scheme, that is a value 4. This means in the employee structure, the 1 bit is used to store the gender, the 2 bits or 2 used to store the marital status, 3 is used for the hobby, and 4 is used for the scheme. So these are the 4 types. This is given, that is 1 bit is used to store the gender, 2 is used to store the marital status, 3 is used to store the hobbies, and 4 is used for the scheme. The colon in the above declaration tells the compiler that we are taking about bit fields, and the number after it tells how many bits to allot for the field. So this declaration colons denotes how many bits are used to store the values. That is, gender takes only 1 value, marital status takes 2 values, 3 values, 4 values. Once we have established a bit field, we can reference it just like any structure element as shown in this one. The male is denoted by 0, female is denoted by 1, single is denoted by 0, 1, 2, 3. So this is how we can use this by using the macros, by defining in the header files, that is hash define male as a 0, hash define female as a 1, hash define single as a 0, married, divorced, widowed. Then using the void main function, that is struct employee, then unsigned, the same 1, 2, 3, 4, then declaring the variable of the struct employee. I'm repeating again. First of all, these macro will be defined in the header files. Then using the void main, then there is a struct employee. That is, a structure is defined that is of that is has a name employee. Then uses the unsigned gender, then unsigned marriage status, then unsigned hobby, unsigned scheme, and that has a value 1, 2, 3, 4. Then closes this structure by using the semicolons, then using the variable name, that is a struct employee, then uses the e dot gender, that is a male, e dot mass status, that is a divorced, e dot hobby, that is a 5, e dot scheme, that is a or scheme, that is a 9. That is given the values. Gender has a value male, divorced, hobby has a value 5, scheme has a value 9. Now printf gender, e dot gender, e dot marital, e dot or size of e. Now the gender is 0. Why the gender is 0? Because gender is of male and male has a value 0 over here. Now marital status is 2. Why? Because this says this is a divorced and the divorce has a value 2. Bytes occupied by E is 2. Why 2? Because it takes only 2 bytes for the marital status. I'm repeating again. This is a program that shows how bit fields is used. First of all, we have declared the macros for different elements like male 0, female 1, single 0, divorced 1, married 2, widowed 3. Then using the void main function, then uses the struct employee. That is, employee is the structure type that contains gender 1, marital status 2, hobby 3, scheme 4. Then declaring the variable of the structure employee, that is as a value e. Now this variable is used to get the or to access the values like e dot gender equals to male, e dot mass status equals to divorced, e dot hobby equals to 5, e dot scheme equals to 9. Then uses the printf for printing purpose. Now print the gender, print the marriage status, print the uses the size of operator for the bytes, how many bytes are used or how many bytes are taken by the bit fields. This is the output, that is gender equals to 0, then 2, then bytes occupied by E is 2. Now next topic is pointer to function. First of all, let's take a practical approach, then moves to the next topic, that is a pointer to function. So let's take a practical approach on the bit fields. So I'm going to start with the program of the bit field, the similar program but a different program. If the similar means the content or the material is similar or the structure is similar but the values are different. First of all, uses the hash include stdio.h. Then uses the void main, or first of all we have to declare the macros also. So I have defined one macro, that is hash define. For example, I have declared the petrol as a one value. In the same way I have declared one more macro or 2 or 3 macros more. So this petrol has a value 1, then there is a diesel, Then there is a two-wheeler, for example, two-wheeler. Then there is a four-wheeler, for example. Then there is a old, there is a new. For example, I have taken these macros. Now it has a value 6, it has a value 5, for example. This is a value 4, this is a value 3, this is a value 2, this is a value 1. Right, now uses the void main, starting with the function, starting with the structure, that is the struct keyword. That is the struct. This is not in capital letter, this is the struct. Then there is a vehicle. For example, I have declared the one structure, that is a vehicle. Then uses the unsigned. For example, I have used the type as a 3, that is yes. Okay, thank you. Then uses the fuel as a, let's say 2. Then again uses the unsigned, for example model, that is, for example, takes 3 bytes, that is a 8 bits. Now I have closed this one. Then uses the struct vehicle, that is a V, for example. Now uses the V dot type, that is V dot type equals to 4 vehicle. Suppose I've used 4 vehicle, so this is 4 the underscore WH. Right, means the type of the vehicle is 4 vehicle. In the same way, for example, I've used 4 dot fuel equals to for example, fuel takes the diesel. Right, there is a semicolon. Then this is small. Then uses V dot model. What is the model? That is either old or new. So suppose I have taken the model as a old, for example. Now clear the screen. Now uses the printf statement for printing the values, that is the type of vehicle, that is the type of vehicle, is percentage %d. For example, now I've taken colon. The type is I have printed by using the v dot type. Then uses the semicolon. Again uses the printf. Then use yes. Pardon? Yeah, yeah. Yeah, sure. Tell me. No, this is also possible. We can use the printf statement for printing the values. Yes, yes. Okay. Yeah, but we have declared this struct vehicle as a v variable. So v is a variable of the struct vehicle already. So no, 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 because it is of unsigned and unsigned has always a value percentage d. All right. Okay. That has also a percentage d, but it is if it is unsigned char that has a percentage c. But if it is only unsigned or signed, that is percentage d. Now uses the curly braces for closing purpose. This is the closing braces. Now if I compile this code, there is a success, there is no error. If I yes, yeah, yeah, sure, sure. The type of vehicle is 4, the fuel is 2, and the model is 5. Why? Because we have the declare or we have used the type of vehicle as a v dot type, and we have already declared the 4 vehicle over here, and the 4 vehicle as a value 4, right? So this is a 4 vehicle that is already declared that has a value 4. In the same way we have declared v dot fuel as a value diesel, v dot model as a value old. So this will be given as a values and this will be given as a output. This is the type of vehicle is 4, the fuel is 2 and the model is 5. Why? Because type is of 4 vehicle and we have declared the macro over here upper above, that is 4 vehicle has a 4, then fuel diesel that has a value 2, old that has a value 5. So the output is 4 to 5. This is the output, that is a 4 to 5. This program is clear to all of you? Hello? Yeah, this program is clear? Yeah, this program is clear to all of you? Yeah, yeah, sure. Can you repeat your question? Yes. Uh-huh. Because we are using this value over here for vehicle and I have to print the bit over there. So we have already defined that the petrol has a value 1, diesel has a value 2, 2 vehicle has a value 3, 4 vehicle has a value 4. So it is declared as a macro, and in this we have defined that the type takes 3 bits, fuel takes 2 bits and the model takes 3 bits. So this is defined, that means type takes the 8 values, fuel takes the 4 values, model takes the 8 values. But I don't know what are the 8 values. So we have declared some values in the header file that is declared by using the macros. Now let's start with the, or let's make another program for the bit field. The same example of this type. Let's see. For example, I've written hash include stdir.h, then again hash include conio.h, right? Then uses the void main. I have to declare that one also. Suppose I've used hash define. For example, I've used pass. Yes. Yes, yes, yes. Thank you. Yeah. We have also used the int main, but at the end we have to use the return 0. Yes. Can you type the question with the help of chat? Yeah, sure. Tell me. I'm not getting your question because the voice is not audible to me clearly. Yeah. The main target is that we are using the bit field so that our memory capacity is saved. We are using only 2 or 3 bits. So when we are using the bits, so our memory capacity, our storage capacity is saved. That's the main target of using the bit fields. But yeah, this saves the memory devices. Now I'm using void main over here, then using the struct student, then uses the structure variable, then uses the char pointer name, then unsigned result equals to 1, then unsigned grade is 2, then uses the curly braces. Now define the variable over here only, that is v, then uses this one, then use the v dot name equals to, for example I've given the name as a Harry. Now I've taken the a result, that is equals to pass, then I've taken the v dot grade, that is either A, B, C. I've taken the grade as a C, for example. right? Now uses the CLR, SCR. Now printf v dot name, simply printf the name is in percentage s, so we have given the percentage s, then v dot name, then given over here, that is printf the result, that is result, that is in percentage d, then uses this one, that is v dot result, then uses the next printf for grade, that is a grade, that is using the percentage d, then uses the v dot grade. Now using the get ch for output, now uses the semicolon for this one, curly braces not semicolon. Now if I compile, there are 3 errors because we have not defined the parenthesis over here, I forgot, then this is an error. Now there is no error. If I compile, execute this code, the name is Harry, the result is 1, the grade is 2. Why it is coming in one line? Because I have not given the percentage n, percentage n, percentage n. If I compile this code, the name is Harry, the result is 1 and the grade is 2. Why? Because name we have already defined that as a Harry, the result we have defined as a pass, and the pass has a value 1. In this we have defined the grade as a C, and C has a grade 2. That's why it is coming Harry 1 2. This is the output, that is a Harry 1 2. Now the concept is clear to all of you? Hello? Yeah, this is clear to all of you? Hello? Hello? Yeah, this is clear? Clear or not? Okay. So that's all for today's session. In the tomorrow's class, I will be starting your next topic, that is the pointer to the functions. So now if you have any doubts, then please text the doubt and I will answer you. In the tomorrow's class, I am going to start with the next topic, that is the pointer to functions. Still now, if you have any doubts, any confusion, then please feel free to ask from me. So thanks a lot everyone for listening me. Bye bye. Yes. Yeah, tell me. Oh, you are Larry. Okay, Larry, you have an email ID with me? Okay, I will send this latest by the tomorrow. Okay, bye bye.